Ahoy mateys! Welcome aboard the SS Optimization for today's Let's Explain Performance session at mongodb.live 2020. This is the third annual installment of our Tips and Tricks for Querying MongoDB series. This is your Captain Chris speaking, and I'm very excited that you've decided to join us on this journey today. So we've got quite the packed agenda, so let's just get right to it. So the first thing we want to cover is actually why you might not need this presentation at all. Next, we'll go ahead and talk a little bit about Oueryland and the 4 regions that are in it that you should just generally be aware of. Next, I'm very excited that I get to share a secret about explain plans with you all. This is the first time that we've been able to share this information, so I'm very excited about that. Next, we will go ahead and outline a legend or a general way to read explain plans. And then finally, we'll get to explore an island by practicing the things that we've learned along the way. So why might you not need this presentation at all? There's at least 3 reasons. The first is our Performance Advisor utility. This utility gives automated index suggestions based on the workload in your environment, and it's quite good. So if you are running an Atlas cluster and you've never taken a look at the Performance Advisor tab, I would highly suggest that you do so, because some of the indexes that it'll recommend will greatly improve the performance and throughput of your cluster. Next, we've got the ESR guidance. So this is just a general rule of thumb when it comes to indexing. We've talked about this in various other forums, and it basically comes down to you placing equality conditions at the beginning of the index, followed by sort and then range conditions. We're not actually going to talk about this today, but it's one of the rules that powers the Performance Advisor and a number of the suggestions that you would get if you were just trying to optimize a query yourself. And then finally, there's actually quite a bit of MongoDB support, both community and professional. So if you have a question, you're certainly more than welcome to ask it. And there's a number of resources that may be able to assist you and give you more specific information about your question and your workload that may not be available in other places. So assuming that you would like to know more about explain plans, because that's why you're here, let's move on to this next section, which is what is Oueryland and what are the 4 regions that I'm talking about? So let's do this by talking about an island in Oueryland. So that island would have a query that arrives on one side, and it would have the results that are sent out on the other side. And then there's a bunch of stuff in the middle. Mainly, you would hear people refer to this as a black box, but it's an island for our purposes today. So to traverse across Oueryland, there's a number of different options. And so sometimes you'll just see a nice quick traversal. You'll see no problems with that. It's very straightforward, and you will never question what's going on. In other situations, you may get a path that's not quite so straightforward, right? You might wander around a little bit, but you eventually get your results, and there's nothing really to complain about. And then there's some that kind of are surprising. They start off and they look great, and then maybe they encounter some problem and they sort of go off the rails after that, right? They are very lost, wandering around. They eventually get the results back, but it's much slower than you'd prefer. It's much slower than your customers can handle. And so we really need to do something to fix this traversal to make it more efficient, more straightforward from getting from the query to the results. So let's take a look at what's actually going on inside of Oueryland. So when this query comes in on the left, we will do a check at first to see if there's a matching entry for that plan shape in the plan cache. Let's assume for the moment that there's no match. Then what we'll do is go through a series of steps to actually build that query, right? So we will generate the candidate plans. We will follow that up by evaluating the candidate plans. We will choose a winning plan from that. And then in older versions of MongoDB, we will immediately cache that entry and then generate the result set and send out the results to the client. Now, in a different situation, let's say that the plan came in and there was a match in the plan cache. In that situation, we're not going to go through that planning process that we just did. We're actually going to just evaluate the plan performance of that plan that's already in the cache. Assuming that that performance evaluation succeeds, we will simply follow that up by generating the result documents and sending it back to the client. Finally, there's one other path that we can do through here, which would be there is an entry in the plan cache for the shape. However, when we try to run it, it's not found to be very efficient. So it fails our evaluation of plan performance. So we actually evict that cache entry, and then we go through the whole planning process again in an operation called replanning. So we're going to evict the cache entry, generate the candidate plans, and go through that whole chain of items until we generate the result set and send it back to the client. So this is overall what an island in Queryland looks like. Just a short disclaimer here, we've actually changed a few things with respect to caching in 4.2, but overall I find that this is a very helpful mental model for me to get a general sense of what's going on, and the details about the cache changes don't actually impact this flowchart very much. So there's actually just really 4 sections here if we kind of break it down, right? So we have a plan generation item, we have a plan efficiency item where we evaluate the candidate plans, we have a plan selection process where we choose from those candidates, and then all that's really left is a plan cache section, right? So these other 4 boxes, they all kind of are related to the plan cache, either generating the item or evaluating it and using it. So actually we can kind of turn Queryland into just an island with 4 regions, right? And so we can take our plan generation region, and that's largely just what options are available to us. We have our plan efficiency region, so this is why isn't our desired plan better when we have our plan selection region, so why didn't we pick a different plan that was available to us? And then finally, the last region in Queryland would be the plan cache region, which is why is daunting different than maybe what is running? So one interesting thing to note here is that some of these borders are actually a little bit nebulous. So some of the regions kind of fight for more land with the others, but in the end, there is some line. It's just a little bit fuzzy on where it is at some points in time. So for each of these regions, they all have at least some behavior that's kind of specific to them. So we could list out, if we wanted to, some items that would belong to each of them. So for example, in the plan generation section, we have an item that it has to be a viable index. So there's some rules that determine whether an index is viable for a query shape and whether it can be used or not. And that would fall under the plan generation region of Queryland. Next, if we look into the plan efficiency section, we could see that maybe somebody made a mistake in the ESR ordering or the ordering of their compound index keys. Maybe they don't have the equality keys first. And so although an index is being used, it might not be as good as we were hoping it would be. So down here in the plan selection section, we have the question of why didn't we pick a different plan? So for example, maybe we have several plans that are available to us, and they're all using related indexes that have the same beginning to the index. That might cause some problems when it comes to plan selection, and then there'll also be some questions of whether or not you would need all those indexes or not. Finally, over here in the plan cache section, this is actually really the smallest of the 4. There's not that many things that can happen in here, but one thing that does come up from time to time would be data skew, and this is usually associated with query shapes or indexes that aren't necessarily well suited for one another. So maybe the environment doesn't actually have an index that is optimal for a given query shape. And so we end up with a sort of difference in the plan that's given to us by the explain output versus the one that's run when you run a query. And that can largely be related to that inefficiency and the data skew that's associated with the collection underneath. So Chris, you've now kind of talked a lot about Queryland, but you actually haven't said anything about explain. So why are you explaining all of this to us? So this is where the fun begins, and I get to kind of walk you through a secret about explain plans that we've realized that we've never shared before. So if we talk about explain plans themselves, we can see that they're, well, complicated, complex, nuanced. There's a lot of different words that we could use to describe them. They generally have lots of output, and what we're looking at here is actually not a very large explain plan at all, to be honest, and I've even truncated some of it. So this is a very small sample of what an explain plan could be, yet it's still a wall of text that is a little bit intimidating to look at. But the good news here, and the secret, is that this is actually just its secret identity to hide in plain sight, but in actuality, explain plans are really treasure maps in disguise, right? So if we kind of take all of this input that's associated with the explain plan, we can kind of determine that there's a few indicators here that may or may not be more important than others, and it may or may not be related to some environmental factors, but generally, these are kind of things that we want to pay attention to. So if we were to kind of remove a bunch of the noise from the explain plan, and then maybe we associate those with some type of landmarks, all of a sudden we get something that is sort of looking like a treasure map with landmarks and stuff like that. If you understand what these landmarks are and what these pitfalls could be, then you may be more well suited to traverse them than somebody who doesn't, right? So here are 3 attempts to wander through Queryland without knowing what these different things are, and people are getting lost and seeing some poor performance because they can't read this map that's given to them. However, you will be able to read these and understand these, and you will be able to go efficiently straight to the treasure at the end. So how do we actually go ahead and read these? So that's what we're going to explore during this session today. So one thing to be aware of is that all islands are unique, right? So every explain plan is different. So some might look like this, others would have similar landmarks but in different places, and then even some more would have them spread out or not even have as many as another explain plan. And this could be for different environments, it could be for different query shapes, it could be for different versions, right? So all islands are unique. But all islands have common regions, and those common regions are the ones that we just discussed, which are the plan generation, the efficiency, the selection, and the caching sections. So now if you're aware of these sections, you don't have to understand all of the little landmarks that could be different or might be version specific or anything like that. You can just have a general understanding of what region you're in, what region you're trying to get to, and that'll allow you to read the explain plan and ask good questions that'll help you get from one region to the next until finally you arrive at X marks the spot. So why don't we go ahead and actually discuss what a legend might be? What are the things that we want to be understanding about the structure of explain plans in general so that we can read them better and understand the region that we're in and how we go forward? So let's talk about that. So first, to actually generate an explain plan, what you want to do if you've never done it before is you can just open up a shell session and you can add the explain function after the collection, and then you can tack on your query at the end, and this will generate basically what we saw before. So this isn't going to be perfect syntax that we're seeing throughout, but it's going to be representative of what you would find in our documentation so that you guys can go and do exactly the same sort of stuff that we're looking at here. So similarly, I've run this explain in query planner mode, which is the least verbose mode, and it's also our default mode, but there are many other options available, or rather there are many additional pieces of information that are available in the different verbosities. So for example, we could use our highest elevated verbosity of all plans execution, which will give us execution stats about the winning plan, as well as information about that trial phase that we talked about earlier when we were in Queryland. Finally, just as a note, keep in mind that we can also run these things for aggregations. So we can do an aggregate and that has a match and a group, and this will still give us information about the planning process itself. And in newer versions of the product, you even get more information about what's happening in each version of the aggregation stages. So that's very helpful information, again, as you're exploring Queryland. So here is the general structure of an explain plan. And again, throughout this presentation, these things are very verbose. We don't have room to show all of them, so we've truncated things a little bit, but it is very close to what you'd actually see if you were to run these in the shell. So if we kind of step through these items, so at the bottom down here, we've got a few pieces of sort of meta information about the cluster. We've got our server info, which includes details about the MongoDB process. You can see that there's a version here and a host here, and there's a few other things. And then at the very bottom, even though I've removed it from here, you will get some additional information such as cluster time and other things like that about when the explain plan ran. Next, up top, we have the query planner section. Again, this section is always present. It's from the default verbosity on up, and it's going to contain information about the query plan. right? So one of those pieces of information is going to be the namespace, right? Where did this explain run? We've also got things like the parsed query, which is how the database understood the query that we sent to it. We've got the winning plan, which is the plan that was actually chosen as the winner from that trial phase we talked about a little while ago. And then finally, you'll have an array of rejected plans. So if there were other plans that were considered, they'll be shown here. The one item that we haven't talked about yet is this execution stages down here. So these are metrics from running the query, but they're only present with elevated verbosity. So both of the increased verbosity levels that we currently have, they will have these execution stats. The lower level of those, which is just called execution stats, will give you information about the duration and efficiency from the winning plan itself. So if your query ran for 45 milliseconds, you would get information about that here. And then finally, at the most elevated level of verbosity, you get this all plans execution entry down here. So these are metrics from the trial phase themselves. What's interesting to note, perhaps, is that these metrics must be gathered in order for the winning plan to be selected. So we basically have to run this regardless of your query planner mode. So if you're already going to get execution stats, you might as well get the all plans execution because it gives you some additional information, especially about the selection process that we can use to better understand the query planning process. So the one other building block that we need with respect to legends for explain plans is actually the details about a plan itself. So this is just a very small snippet of what a plan might contain, and effectively it's a child-parent relationship of stage or stages. So here we've just got two stages. We've got the top level fetch, which has a single input stage of an index scan, and inside of each of the sections you'll get information about what they're doing. So inside of this index scan stage, we've got information about the index bounds that it used. So it looked for a specific string and it only looked at keys related to that string. Whereas in the fetch section up top, we had to apply a filter to do more reducing of the result set to get the actual data that we wanted back to the client. And again, if we increase the level of verbosity, you'll get some additional details here, such as the number of documents that are returned from each stage, which also help tell us how efficient a stage is, how selective a particular filter might be, and those things are all important when it comes to query planning. So here, for example, we can see that the index scan stage found 327 index keys that might be associated with documents that should be returned. We returned all of those up to the fetch stage, but the fetch stage filtered out about 2/3 of those and only returned 101 up to actually be returned back to the client. So we've set the stage now. We've talked about Oueryland and the 4 regions of it. I've shared the secret that explain plans are really just treasure maps, and I've given you some basics about what an explain plan looks like. Now, it may seem unlikely that we can take just that and start making sense of these really complex explains, but I promise you that we can, and we're going to do that by practicing. We're going to take the basic information that we learn, and we're going to start stepping through it and seeing how it gets applied to an actual situation. So to do that, let's go ahead and map a couple of the things that we've talked about together. So we have our regions over here. So the first region we talked about is our plan generation region. So as a handy guide, let's say that maybe the thing we want to think about is, are we looking at the right map / are we on the right island? Okay, so similarly, let's say for plan efficiency, that we associate that with seeing the expected landmarks on the map that we're looking at. Next, we would have plan selection, and we can kind of imagine that as making sure that the treasure chest is actually buried in the right spot. And then finally, we said we had the plan cache section. So that's sort of like making sure that the treasure chest actually has something in it. It's not empty. Okay, so now with that guide in mind, let's turn those back into actions that we can use on the explain itself. So for plan generation, making sure we're looking at the right map, let's go ahead and check environmental information on the explain itself. For checking to see if we have the expected landmarks, let's go ahead and check the index bounds and their efficiency and items related to that. So for selection and making sure that the treasure chest is buried at the right spot, obviously you want to check the winning plan, but you also want to review the trial period, the metrics from that trial period, from those elevated verbosity levels, and make sure that they're as expected, because they may not be as intuitive as you may expect at first. And then finally, although it doesn't come up that often, occasionally our treasure chest is empty. So what we need to do in that situation is just double check on the cached plan. So to help with this, let's say that we are running a production environment and we have steadily been seeing a query slow down more and more. So finally, it's to the point where we can't ignore it anymore. We go in the log file and we find something like this. You'll notice here that, again, we have sort of a wall of text, but that's not necessarily something that we need to shy away from. So there's a few really important pieces of information that we can pull out of here. The first is that at the very end, we've got the actual duration of the query. So this query took about 1.2 seconds, and we can find other environmental information about it earlier in the section. So we can see that this was a find query on the gaming.scores collection. So we applied a filter in here. So we were looking for a game called Minesweeper, or a document with entries for a game called Minesweeper and scores of greater than 9,000. And we can also see that we had a plan summary that did do an index scan, but it was only on one of the fields that we actually searched on, which is an interesting observation just right off the bat. Then we can also see in here that we've got some information about the metrics for the execution. So we can see that we examined more than 200,000 keys, which is quite a few. And for all of those, we went and pulled the document and looked at the document as well, which seems suboptimal. And indeed, if we go and look at the number of returned items, we only had 101 returned items. So if you've ever been running an Atlas cluster and you've seen a query targeting alert, this is sort of the stuff that it's talking about. Is this operation went and scanned a whole lot more data than actually what was requested and needed by the client. So this is our slow query in production. So let's just double check to make sure that this isn't the only index available. So what we'll do is we'll go run the get indexes command on the collection, and by default there we have the underscore ID index. We've also got two others. So we've got that title index that we were just talking about a moment ago, and then interestingly we do have a compound index here. It has score and title, and those are the two items that we queried on. So we would sort of expect this index to be used instead of the title index. So let's start unraveling that and figuring out why it wasn't. And to track our progress along the way, we're going to be referring back to this little map. So we're going to start over here on the left, and we're going to make our way through the island as we explore. So to begin, let's talk about the plan generation that we're seeing with our first explain plans. So this is what options are available to us. So plan generation number 1. In here, just as a quick observation, we have a stage EOF as the winning plan, and that just doesn't seem like anything that we've talked about yet, right? We've talked about collection scans and index scans, but nothing about EOF has come up, so it strikes me as a little bit odd right off the bat, right? But regardless, let's go ahead and refer back to our guides and our actions. So we want to make sure that we're looking at the right map here, we're on the right island, so we need to go ahead and check the environmental information in the explain plan itself. Okay, so going back to that explain plan, let's go ahead and start checking that environmental information. The first thing we're actually going to check is the namespace, which is up top here. We can see right away that the collection name is correct, which is scores, but unfortunately the database name is not correct here. So this test database, that's going to be the default database that your shell connects to if you don't specify anything else. And so what seems to have happened here is the person generating the explain didn't actually set their database environment variable correctly. And so we've got an explain from a collection that doesn't exist, which is why we ended up with this EOF stage in the winning plan here, because we don't have an actual collection to do a query against. So with that, we've actually made our first sort of exploration onto the island, right? So we've now gone from the shores and we've hit our first landmark over here. So that's great. We now understand that we're firmly in plan generation area and we need to keep moving towards plan efficiency. So let's keep exploring. Let's now go generate the explain again, but we've corrected the namespace. But interestingly, we see that once again we have this EOF stage, which doesn't make sense, but it doesn't necessarily have to. We don't have to know everything about the explain in order to continue moving throughout the island, right? So we're still in our plan generation, our map environmental variable section. So let's go check those again. So we go and review our namespace, and this now seems correct. We've got our namespace, which is gaming.scores, which is awesome. The other piece of information that would be really important here would be the host name. So down here at the bottom, we've got our server info section, and it includes our host name. And here we've got localhost, but we know in our example that localhost isn't one of the systems that we use. We can't connect to localhost for the development of this query. So this one doesn't make sense either. It must have been run on somebody's machine. And so actually we can throw this one away too, because it's not very meaningful to us. And just like that, we've already gone through 2 of the items in our plan generation, trying to make sure that we get towards our plan efficiency section. So exploring this next one, what we've got here is something a little bit different. We've actually got a collection scan here, but per our process, let's go ahead and check our environment information. So we have run this against the correct namespace of gaming.scores. And now we've actually moved on to our development host. So the information is more relevant. And hey, we've actually got a collection here because we're now doing a collection scan. So further to that, let's go ahead and check our parsed query. So we've got 2 fields here. We've got the check against the game name on Minesweeper, and we've also got the check against score. In this particular case, we're looking for greater than a given value. But one thing that's particularly interesting here is we definitely had indexes, but we don't see them used here. We just see a collection scan stage. And if we look closely, our score field name here, that doesn't look right. So if we go back and pull our log entry, it's actually a lowercase score that's used in production. And so we're actually not even querying on the same field here. It looks similar to us, but to the machine, these are very different fields that have nothing in common. So we can't use the index that's for lowercase score when we've got an uppercase S for our field name here. So this is actually the reason that we're getting a collection scan. So we do have the collection existing. We have actually looked through it to find some stuff, but we actually won't find anything since we're searching against a field that doesn't exist in our collection. So we're actually firmly moving through our plan generation region here. We're almost to plan efficiency. So let's go correct our mistake with our casing for our field name there. And let's go ahead and take a look at the next updated explain. So the next update explain is going to be in the plan efficiency section, which again is why isn't our desired plan better, or why isn't it running as quickly as we would have expected at first? So here's our latest explain. So let's go ahead and once again just run through things. As a first observation, we do now have an index scan stage in the winning plan, which seems like we're moving in the right direction, right? We're not getting an EOF, we're not getting a collection scan, we're actually having an index scan here. So we're definitely venturing into plan efficiency region now. So once again though, we're still in the first part, so let's double check our environment variables. So we've got our namespace, which is correct. We've got our host name, which is correct. So now, as per the guide that we set out earlier, we want to move from that environment stuff to the landmarks, and we want to start checking the indexes and their bounds and their efficiency. So let's go ahead and do that. So what we want to do here is we've got this compound index in the winning plan. So on the first line here, we've got a score, and we can see that the bounds here of greater than 9,000 map directly back to what we see in our parse query, which is great. But interestingly, in this other field in the index scan, we've got min key, max key, and I don't necessarily know what that means, but in the query itself, we've got an equality condition against a string. So that doesn't make sense that those two don't look like each other when the scores looked at each other. So when we actually take a look at the field names, we can see that, oops, we've made another mistake. In the index and in the actual items that are used, the documents, they have field names called title, where we've mistakenly queried here on name. So this is exactly why we're not bounding this index very tightly, and that's going to lead to some poor performance. But there's one other interesting observation that we can make here, which is earlier we said that there were two indexes that seemed like they were relevant to the query. But here we've got no rejected plans. So our typo here has actually turned this into a plan generation problem as well, because now we've only got the one plan that was generated. The other plan wasn't even generated, so it couldn't be evaluated, or of course it couldn't be selected for use. So it turns out that this explain is sort of right in between the land between these two regions, but we're definitely venturing into plan efficiency space now, and we're sort of moving away from not generating plans at all, which is great. So now we've come to our next explain, and once again we've corrected our mistakes. So what we can do here is we can start taking a look once again at our items. So we start off with our environment, just like always. We check the namespace is correct. We check the host is correct. So now let's start taking a look at those landmarks, at those indexes and their efficiency and their bounds. So similar to earlier, we've got our index bounds that we can check in our winning plan. And in this case, these actually seem much better. So our winning plan here is just on the single field index of title, but we have tight bounds based directly on our equality check against the Minesweeper field. Next in the parse query, we've got the score check itself, and we can see that both the title and the score are tightly bound in the other plan that was considered. So we can actually see something interesting here, which is in the winning plan, we've got our single field index, whereas in the rejected plans, we've got our compound index. But since the compound index has both of the fields that we're after, we're sort of expecting that to be chosen as the winning plan, right? So as a reminder, as part of the section, one of the other things that we want to do is check on the efficiency of the operations as well. So let's go ahead and do that. So down here at the bottom, we've now generated our execution stats for this plan. And so when we take a look at them, we can see that it ran extremely fast. It was done in less than a millisecond because our total execution time was reported as 0 milliseconds. This would seem great, except there are no keys examined, but that doesn't make sense, and there were no documents returned. But we absolutely know that there were documents returned in production, so this doesn't make sense. So what the heck is going on? Well, recall that we're now running this on our dev host environment, but this host unfortunately doesn't have a collection that is set up similar to production. We've only got a few documents in there. It's sort of just a proof that specific things are working, and it's actually not a very good reflection of what we're trying to do in production with production level data. So lesson here is to definitely run your explain plans on environments that have similar size data and similarly distributed data to your production environments, as is pretty important to actually getting those real world results that you can then use to make real-time and better decisions about your indexing strategy. So what we're going to do is, for all future ones, until otherwise noted, we're actually going to run them on a QA host that, for our purposes, has similar data to production. I'm also going to trust you guys and say that we're actually not going to check our first couple of items here. I hope that you've gotten used to the general process here, but I do want to remind you that it's very important to do so, because as soon as you don't, you'll likely get lost in plan generation land without knowing it. So let's go ahead and take a look at where we're at on the map. So we've now traversed all the way from landing on the left side of the island, all the way squarely into the plan efficiency space. And now it looks like we're about to start traversing into the plan selection area. So plan selection, why didn't we pick a different plan? Which is exactly what we're asking about here. So what we're going to do as part of this is we're going to now again generate a new plan. And so we've got our query planner with our winning plan here, which is not the index that we're expecting to win. And we're also going to gather the execution stats in the most verbose mode, which is all plans execution, which is going to have those trial period details. So reviewing our guide and our actions, we want to actually see if the treasure chest is buried at the spot. Are we getting the right winning plan? The one we're looking at is actually not the expected one. So let's review our trial period metrics to better understand why that might be happening. So to break this down, we've got two plans that are currently considered here, one for each of the indexes. And in our all plans execution, one of those plans looks like this over here on the left, and the other one looks like the one on the right. So again, our winning plan is the single field index. So from the all plans execution entries, that maps back to our entry on the left over here, which is just the index on title. Whereas the other entry that we've considered is this compound index on both of the fields. So let's talk about some general observations about these metrics. Up at the top, we've got our total keys examined of 327. Those are the same for both of the systems. Moving down and starting at the bottom on the innermost section, we've got our index bounds for each of them. These are going to be related to obviously what we're scanning when we're looking at the indexes. And inside of them, we can see obviously title was evaluated for both. But unfortunately, score was only evaluated on the right one, whereas score had to be filtered in the fetch stage on the left one. And again, this general information is just looking at the explain and sort of figuring out where the different pieces are rather than sort of memorizing what's going on, right? So we're just observing that the score bound is present in the index scan stage on the one on the right, whereas that same filter for that field is applied in the fetch stage on the one on the left. So for the compound index, when we bound on both things in the index scan stage, we're actually only returning 20 documents despite having scanned 327 keys. Those 20 documents get passed up to the fetch stage. They immediately get passed back up because there's no additional filtering to be done. And at the top level, they would have been returned back to the client, but this is just during the trial phase. So if we then go look at the actual plan that won on the left, we've got that we only scanned on that single field in the index, and because of that, and because the index was tightly bound, all of the index entries that we found were then passed up to the next stage. So all 327 were passed up to be evaluated by the fetch stage. But when we went to apply that filter that we talked about, that resulted in us reducing that result set by about 2/3, and we only ended up returning about 101 documents from the fetch stage. So these then went up to the top level, and this helped the trial phase terminate. So when we went to actually select the plans, all we need to do here is take a look at what the rough efficiency looked like. And over on the right, we have that we only returned 20 documents despite having scanned 327 keys, which doesn't look very efficient. Whereas on the left, we returned 101 documents, or roughly 1/3 of the index keys that we examined, which was deemed to be more efficient. And this is why this plan ended up as our winning plan. So now we've got at least some understanding of the plan selection, right? We've got at least some information about what's happening. And even if we don't know exactly what to do, we can simply try something here, which is we have a single field index on one field. We have a compound with the fields basically reversed. That one field is in the second position. So maybe we could just try and add a new index, which has title first and then score. And let's just take a look at the explain and see if anything is different. So now we've generated our latest explain, and we can see in all plans execution that we've actually got 3 different entries here, whereas before we had 2. And so now when we jump ahead to check our plan selection details, we've got this plan, which is the previous winner, and we've got our new plan, which has the new index on title and then score rather than the other way around. So interesting, in our winning plan, we actually get that it's the new index. So let's quickly check why that is. When we take a look at our title single field index over here on the right, we did just look at the entries in the index that had Minesweeper as their key. We returned 101 from the index scan, and similar to before, we filtered out about 2/3 of them during that fetch where we removed the scores that weren't correct, and then we returned about only 31 of those from that stage back to the client or the termination of the trial phase in this period. On the other side, we've got that we were able to check for both of the items in the index, and we returned 101 documents from the index scan stage. But since in the fetch stage, we didn't need to do any additional filtering, those got immediately passed back up, and we ended up with a ratio of 101 documents returned to 101 documents or index keys examined, as well as documents examined, which is the perfect ratio, and that resulted in us selecting this plan as the winning plan, which is what we were going for, which is we want to improve the efficiency of this operation, and we seem to have done so with this better 101 to 101 ratio. So returning to our island, we've now generated a new index. It's now being selected as the winner, so we're almost to X marks the spot. The final little step here is, why is daunting different? So in some cases, like the one we were just looking at, we actually get the right winning plan, right? So we've made this new index, and when we run explain, it gets selected as the winning plan, which is great. And in our guides and actions, we need to check to make sure that the treasure chest isn't empty, that we're actually running this plan in the production environment. So when we do so, we're going to go and pull the latest log entries, but what we find is that even after we created this background in the index, we're still using this old single field index despite the explain selecting the new one. So what the heck is going on here? Well, I promised you guys to not forget about those earlier steps here, and if we go way back and we check our environment information once again, we see that we're running on version 4.0.18. And in 4.0.18, there's a few differences in the plan caching and how background indexes are built and how those interactions occur. And unfortunately, the old plan got inserted back into the plan cache as we were building the new index, and we haven't been able to remove that yet. But because we've actually got this new index, we can think about dropping the old indexes, right? So it doesn't make sense to query on a score without a game, so we can just remove that index altogether. And the single field index that we have here on title, that can be handled by this compound index that starts with title, so we can drop both of those. And the effect of dropping those queries is that we actually clear out the plan cache. So once we do that, we've got this additional piece of information. We've dropped the old indexes. So let's go once again. We've got our winning plan, which is correct. And also now in the logs, we're getting our new index used, and we can see that the ratio is much better, as well as the execution metrics. So to summarize what we've just been through, I first told you about why you might actually not need this presentation. And that's largely because we've got automated tools that will suggest indexes, and we've got general guidelines on how you can create indexes. But occasionally, it does pay to know how to wander through Oueryland using an explain plan as a treasure map. And in order to do so, we discussed what Oueryland is, the 4 regions of it specifically, those being plan generation, plan efficiency, plan selection, and plan cache. Then I got to share the secret with you that explain plans are actually treasure maps. We discussed an overall architecture for looking at explain plans. So I gave you the general structure of an explain plan and walked you through a guide that tells you what to look for next. And then finally, we practiced all of this by exploring the island, and we ended up walking from an explain that was indicating an EOF, which didn't make any sense, and a production system that was running slowly, to a highly optimized production system that didn't even have any duplicate indexes. And this was all just by understanding where we were on Oueryland and where we wanted to go next, and just looking at the right pieces of the puzzle to get there. So thank you very much for your time. Please remember to rate all the sessions. Your feedback is very important to us, and I hope that you enjoy the rest of your conference.